same thing applies if we have cubic roots, for example. So let's take a simpler example with cubic roots. Suppose we have the cubic root of 4/5. Remember that one of the things that you were asked to do was to have no fractions inside radicals. Well, we can take care of that because this is the same thing as the cubic root of 4 divided by the cubic root of 5. We can use that property of quotients. Okay. Now, this 1 5 factor, we need 2 more 5 factors to make that a perfect cube. So we're going to multiply that, the denominator, by 5 times 5, the cubic root of 5 times 5. That's the same thing as multiplying by 25, right? By multiplying over the cubic root of 25, that's just equal to 1. But notice what happens now in the denominator. We have the cubic root of 5 times 5 times 5. That's a perfect cube. And so the cubic root of a perfect cube is just simply the number 5. Or the cubic root of 125 is just 5. We've denominator. Now what do we have left in the numerator? In the numerator we have the cubic root of 4 times 25. 4 is 2 times 2. 25 is 5 times 5. We get, we can go ahead and write the answer as the cubic root of 100 over 5. Now, have we said remove something to the outside of the radical from the 100? But notice that 100 is the same thing as 10 times 10, or 2 times factors. There's nothing that we can remove to the outside, and so this is as simple as we can have it. The cubic root of 100 over 5. One warning, be sure and do not cancel the 5. 100, it's the cubic root of 100, which is a much smaller number. Okay. All right, let's look at another example. The process is, however, the same. So we will look at the cubic root of 1 over 2 times x squared times y. Once again, we've got a fraction, a rational number in the denominator. We don't want to have that. So we will say this is the cubic root of 1 divided by the cubic root of 2 times x squared times y. We can do that because of the property of quotients of radicals. Now, we've got something in the denominator. We need to make a perfect square. And this number may be a little small to see, so let me go ahead and rewrite it. The cubic root of 1 in the numerator is just a plain 1. In the denominator, we have the cubic root of 2 times x squared. All right, let's go factor by factor. We need to make the 2 a perfect cube. And so we're going to multiply by the cubic root of 4, because 4 times 2 is 8. That gives us 3 2 factors, which means a perfect cube. We've got an x squared. All we need for that to be a perfect cube is to multiply it by x. We've got a y. We need to make that a perfect cube, so we multiply that by y squared. It's the denominator which determines what it is that you multiply both numerators. So since we've multiplied the denominator by this number, we need to multiply the numerator. Okay. Now, the numerator then is going to be the cubic root of 4xy squared times 1, so it's just simply the cubic root of 4xy squared. But for the denominator, we're going to have the cubic root of 2 times 4, which is 8, x squared times x, which is x cubed, and y times y squared, which is the denominator. So we can say the cubic root of 8 is 2, the cubic root of x cubed is x, and the cubic root of y cubed is y. So what we have then left is the cubic root of the numerator over 2xy. And there's nothing we can take to the outside of the radical from the numerator because we don't have perfect. The cubic root of 1 over 2x squared y. Just simply think what it is that we need to do to make each one of those factors a perfect cube. For example, the 2 to become a perfect cubic root of 4. And the same thing for each of the other factors. Take your time, and you should have no problem with this.